be a lot of fun. They can be very useful when you are creating VBA applications with Excel. So what do we do with them? Well, first, we need to understand that they are a data structure. Data structures are used in memory, so they're used during the processing of code. And the key is with arrays is they allow you to create groups of variables, the key being the same data type. So oftentimes we have data in a worksheet and we want to bring it into our code in order to process from it. So that's what arrays are used for. And you can see here they can be of data type string, double, integer. They just need to be the same data type. Arrays are like an object. So as we've done before, we've used ranges, and you want to think of it when you're writing code as the same sort of thing. It's an object because it is more than just a single location. So with a normal variable, we create that location in memory using the dim statement, and of course we have to give the location a name to reference it in our code. So here, the third thing is it's got to have a data type declared, which is in this case string. Now contrast that with an array. Array starts the same way. You're declaring and reserving a place in memory, but now you're saying a certain amount. Here is how we note in our code in the declaration that this is an array. And of course we still have the data type. And here it says 1 to 5, so you've set aside 5 locations in memory. By default, arrays are referenced by an index, and it starts with 0. That's the default, to start with location 0. So here you see is another way to declare an array, just saying how large you want it to be. And here then it's going to start with 0, 1, 2, 3, 4, because that is 5 locations. And if you want to reference any one location, you're using the index. So here, index 2 contains the value of C. Now often it's easier to always have it start with 1 instead of 0. And that occurs because we're able then to use the index also as our offset. I'll show you an example of that in just a minute. To do that, you have to put option base 1 at the top of a module. And that automatically then changes all array indices to start with 1. So, for example, we have our declaration again. And now the value in location 1 is A. There is no location 0. So this time, if you say first name at indice 3, or index 3, it has a value of C in it. And you would use this, like in an assignment statement, you have after this the assignment operator equal, then on this other side to the left, you'd have some sort of other single variable that would then hold the value of C. So here we have some code. It's a little macro. We start by declaring our array. This time it's a double instead of an integer. We have a local variable I as integer and initialize it. And very commonly, because we're dealing with a group, you will see for loop blocks. And that's what we're looking at here. And I is our variable to navigate that for loop. We're going to go 1 to 5. And you can see how I is being used to reference into the array locations. Just to put some data in there, we're taking the square root, since we're taking that index I times I. So at the end of this for block, at this place, what you're going to see in memory, I want to emphasize that, this is in memory, is 1 the first index, then 2, because 2 times 2 is 4, 3 times 3 is 9, etc. So the next thing with this line of code, we've got the name of the array, price list. See, it's right there. And location 3 is going to have a 9 output in the message box. Now let's look at some more code, and we'll need some data to do that. So we've got a little example worksheet with favorite number, and we have 5 favorite numbers here, listed in one in each row. Starting the macro, we again are going to declare an array. Notice that you do not have to say how large the array is. All you're doing with this statement is you're saying, I want to have an array, it's going to contain integers, and I'm going to set aside some amount later. So it's just saying I'm going to have an array, size to be determined. Then we have local variables to account for the number of rows, and again a loop counter. Now this line of code should be familiar to you at this point. We're using ranges of ranges notation and the Excel down to try to determine the count on the number of rows. And we keep that count in our local variable n rows. See, using this sort of technique, it wouldn't matter if we have 5, 10, 20, etc. The code would handle it. Now this is new. This is called redimensioning. So you do that in order to now adjust the size of the array. So you can see here we're using the n rows that we just determined, and we're setting that to be the correct size of the array. Now we go into our for loop block, and we're able to move data from the worksheet into our array in memory. I want to just take a little tangent and remind you of this point before I continue, that you always should move data from the worksheet into memory and use it for processing, and then you put your results from the processing back, oftentimes into a worksheet. Just wanted to remind you of that point. I talked about that early in the semester, but I haven't mentioned it for a while. So that's why we need arrays. We need group of data structure that allows us to have a whole group of data as we process with it. Okay, back to the code. I told you we'd see an example of this, so here it is. We're using this I loop counter also as the offset variable. So here you can see we're varying the row. The column is always 0 because remember our data was just vertical when 1 in each row. We're taking the value out and we're putting the value into the array, fav number. And again, we're using I as the index as well. So as the point we're done with the message, or excuse me, the for loop, all the data from the worksheet is now in the array. And just to demonstrate that, we're just taking one value out, again, location 3. So at the end of this message box, if we go back, one too far, it's going to be 1, 2, 3. The value of 14 is going to be displayed in a message box. So here's another example, and I want to emphasize something. The code from here down is exactly the same. What is different is after you put the data in the array, it's getting redimensioned again. Mostly you wouldn't want to do this, but it's mostly, I'm doing it for the sake of emphasizing something. When you redimension, it clears it out. So we just got done putting those 5 values into the array, fav num. But at the end of this block, for block of code, they were there. But when we redimensioned it, making it larger, it removed what was in the array. I want to really emphasize that because that can be a logic problem in your code if you forget and you just put redim, I mean. So at this point, when you have a message box output, no matter what location, it's going to be empty. So how do we get around that if we need to make it larger? Because we don't want to remove our data in the array, but we need to make it larger. Well, this is what we do. So here again, this code is the same, so I won't talk about it again. But now, when we redimension it to make it larger, I'm using this keyword preserve. When you put the keyword preserve there, then what you put is still retained. So now, when this message box is displayed, the 14 will be displayed in the message box. Okay, so that's an important thing to remember. If you want to keep what's there and you're making the array larger, you got to use the keyword preserve along with the redimensioning. So in addition to single dimension arrays, one column, you can have multi-dimensional arrays. And we're used to seeing that because worksheets are 2 dimensions, right? We got two ways. We can either go down or we can go across. And so basically they're going to function the same way as the same principles for a single dimensional array. The difference is we need multiple indices. So we need one for the row and one for the column. We've been doing things like this with the offset and the cell, so hopefully you're comfortable with this kind of notation. We just also apply it to arrays. So here's an example. Right now, this is in a worksheet. We just changed the display so it's numbers. We don't have the letters A, B, etc. across here. And I want you to note something we're going to do, because sometimes just because you see it like this in a worksheet doesn't mean you have to move it into an array in the same way. There may be various reasons. You may want to output it in a different way. So notice what I'm doing here in a minute. The first thing here I want to emphasize is that even though it's 2 dimensions, it still has to be the same data type to be in the same array. So in this case, these are all string values, so we could put all of this, what's heavy bold, into a single array. So let's look at some code. Here's how you declare a 2-dimensional array. We still use the dim. This one's called person, but you see you say we want it to be 1 to 5, 1 to 3. Now notice this. Let's look at our data again. Remember, this is our rows. We don't have 5 rows here, but we do have 5 columns, and we only have 3 rows. So right there, that kind of should key you off that there's something going to be done a little different in the code, because this doesn't correlate with how you see it in this worksheet. We've got some local variables. Because we're dealing with 2 dimensions, you should expect to see nested for loops, which is exactly what we see. We have the outer for loop, which is going to go 5, and then we have the inner for loop, which is going to go 3. So again, if we go back to our data, this is very interesting because we know we have 5 columns. So in essence, this outer for loop, and we can tell because J is in this location, the column location, we are going to be traversing across the columns after we fill in each row. So that's what's going on here. Remember, the inner one is kind of what happens first. So we got 1 to 3, and I want to kind of go back and emphasize this again, because that's where it gets a little confusing in nested for loop code. What's happening here is you're going to start right there, but the inner one is going down. So it's going to go down, 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 then it's going to move to the next one, and then it's going to go down, down, next one, down, down. And I know that because of the inner one gets processed before you move across. The outer is what's causing you to move across to the next column. So this code, because you're reversing the I and J in the worksheet compared to where you're putting it in the array, it's reversing the dimensions. The array is going to be 5 rows and 3 columns, but in the worksheet we have 5 columns and 3 rows. I intentionally use this example because this was intentional, because usually you'll want to set up the array the way you want the data output. So that's another purpose for arrays. You take it from a worksheet, You manipulate how you want it to be output, maybe perhaps in a different worksheet, and then you just output it from the array that way. So here we've got a message box, and it's going through. This is after the for loop where we just moved one row set. It's like moving one column in, but it's in a row, and that's why the J is in the row position when it's output. And so what you're going to see, now granted I don't have names here, I just have these initials up here for the sake of space mostly, but what you're going to see when this macro is totally done running is this. You're going to see names, and then their sport, and then what they've accomplished in their sport. So this is a message box, but it could have been being output into another worksheet. I've just put it here like this because I think it's easier to understand how we reversed positions. Before, the names were across the top. Now they are going down vertically. All right. Going on. What we have here is, what if you have a situation where the data is not all strings? Like here we have all string values, but maybe you had salary that you also wanted to track, and you perhaps wanted to do salary increases, so you were doing some processing. If you just have a string value of a number and you're not going to process with it, you can leave it as a string. But if you're going to do calculations, you've got to convert it from a string to a number so that you can do the math, and then output it as a number. Well, in that situation, you cannot put them in the same array. So what sometimes people will do is they create what is called parallel arrays. And we're using some code here to show you how parallel arrays work, even though none of it's being calculated. There's no variable type changes. These are all still strings, but you get the idea by this code. So in this case, see, we have 3 different arrays, and they're all one dimension. If this was a 2-dimensional array, you would see a comma in the declaration showing that there's 2 dimensions, which they're not. It's not there. You have local variables again, loop counter and number of rows. So this part is the same. And then these are all exactly the same size. That is another reason that sometimes you'll use parallel arrays instead of multidimensional, because say like one of these columns had more data than another. But in this case, they're all the same, so they're all redimensioned to that number of rows. We have our block, for block of code, where we're moving the values from the worksheet into memory in each array respectively. And so notice here, the I is just going down the rows again, but we're picking up the 3 different columns. So the person is going to be in column 1, and then the profession in column 2, and the award in column 3. Now we have a for block to output them. So in this case, we're putting it again in a message box, but we're just iterating through the arrays. That's why we have a for block, to move through the whole group, and we're just building an output for each one. So the user would end up having to click OK, that they saw the message box each time. All right, so I am done. I hope you found the arrays to be helpful.